the saga continues. Where we left off, Officer Olivo was in hot pursuit of the evil physics teacher, Mr. Grooby, for illegal degree usage and denying the existence of radians. Officer Olivo is at the top of a police watchtower 1,700 meters from the border of the physics teacher's property line. His high-power flashlight is rotating at 12 revolutions per 5 minutes. Mr. Grooby's lair is 500 meters from the point on the property line opposite the watchtower. How fast is the beam moving along the property line when it passes Mr. Grooby's lair and Officer Olivo finally stops his crimes? Let's get started.
Okay, so we know that the police watchtower is 1,700 meters from the border of the physics teacher's property line. We know that the lair that Mr. Grooby is hiding in is 500 meters from this point. In order to find this other side, you're going to use the Pythagorean theorem to find the other side. So you're going to have 1,700 squared plus 500 squared is equal to c squared. Once you solve for that, you find that c is equal to 1772. Next, you know that you're going to need to use a theta instead of revolutions per minute. So, in order to solve for d theta, you're going to do d theta over dt is equal to 12 over 5 revolutions per minute times 2 pi radians per minute. So the reason we're using radians here instead of anything else is because you can't plug revolutions per minute into your calculator. So we have to make it a unit that you can use. So once you solve for your d theta dt, it's going to come out to be 24 pi over 5 radians per minute. After you find your d theta dt, you can begin to set up your equation. So what we're going to use is we're going to use our trig functions. We're going to use tangent of the theta in order to find our x. So once you find your d theta dt, you can start setting up your equation using your trig functions. So you know that this is your 1,700 and you want to find your dx dt. So we're going to have to take the derivative of that in order to find it. So you want to set it up to where you have 1,700 tangent theta is equal to x. So that once you derive it, you will have your d theta dt and you will have your dx over dt, which is what you are trying to find. Once you take the derivative of this, you are going to get 1,700 secant squared theta d theta dt is equal to dx dt. In order to find what your secant of theta is equal to, all you're going to do is the hypotenuse over adjacent, which is going to be 1,772 over 1,700. So once you've found all of the values that you need to plug into your equation, you just start to plug everything in. So you're going to have 1,700 times 1,772 over 1,700. And that has to be all squared because you have your secant squared here. Now you do times your d theta dt, which you know is 24 pi over 5. And then you set that equal to dx dt. Once you've plugged in all of these numbers to your calculator, you find that dx dt is equal to 27,852.8489 meters per minute. Do not forget your units because that is very important to the problem. Oh, for the love of degrees.